All right, so inequalities, as you can see here, they don't have an equal sign. They have one of these. Also here, we don't have an equal sign. Instead, we have these. That's why we call them inequalities. Inequalities, not equations. Equations have equal in them. That's why they call equations. Most of the work we're gonna do on these inequalities is similar to what we've done with equations. Just gonna add a couple more steps. So the equation or the inequality could be in this form, which is what we call the YMX form. YMX plus B form, or in this one, which we call the standard form. And we've learned how to basically work with both. We'll learn how to graph both, at least, equations. Today, we're going to see how to do with inequalities. So basically, we call these linear equations two variables because we have x and y, usually two variables, as opposed to the inequalities we saw before the midterm. We had inequalities, but they only had one variable. For example, 2x plus 3 is less than 5. We had only x, okay, one variable. That's why we only needed one straight line to graph. If you remember, sometimes we go like that, other times we go the other way, either this or something like this. This was the one variable, but today we're going to see with two variables. So with two variables, we're going to need two axes. We're going to need the x. This was the x. We're going to need the x and the y. And usually these, when we graph them, they're like a straight line. After we graph them, we need to shade one side, either shade this side of the line to be the solution, or we shade the other side. But we don't just shade one side randomly. We have to figure out which one needs to be shaded. So this is what we're doing today. Two variables. It's going to look like this. This is what we've done before in the midterm. Before the midterm, we've done one variable, only one horizontal line and the number line. Okay, so let's see an actual example of an inequality. Okay, so solving by graphing. Let's take this one, specific one here. So y greater than 2x minus 3. An inequality. So we're gonna need, let's see if I still have a graph here. No. We're gonna need a graph to put the inequality in. Once you have a graph, let me get a copy and paper from online. Once we have our graph, then we can shade one of the sides of the line. Okay, so always going to need one of these. All right, so we're going to graph this here. It's going to be some line, and like I said, we're going to shade one. So this is in a YMX plus B form. So this is again what we call the y-intercept. This is what we call the slope, m2 or 2 over 1. So again, we'll call the rise and run. Rise over run. All right, how do we graph this again? Where do you start from?
From the x-axis? From the slope?
Before the slope, we need to start from a
y-intercept.
The y-intercept, that's right. This point is called the y-intercept because it's always on the y-axis. You're going to find that point here, -3. That's our first point. We just need to get to the other point, whatever it is, for example, here, and then we're going to draw the line. To get to the other point, we need to do what we call a rise and run. From this point, we're going to rise and then run. So which way do we go from -3? Start with the rise first.
We go up 2.
That's right. 1, 2.
And then we go to the right one because it's a positive one.
Exactly. We go to the right ones. So depending on the sign of this number, you could go up or down. This one left or right. So again, up or down for the rise. So if it's positive, we go up. If it's negative, we go down. Same thing with the run. It's either left or right based on the sign of the number. So it's very simple to graph using the rise and run. Start from this on the y-axis, rise and run. Go up 2 to the right once. Start from here, go up 2 units, 1, 2 to the right once, and that's it. That's the line basically. Now we're going to draw the line and shade one side of the line. Before we draw the line, there's something we need to pay attention to here. The line is either solid or broken. Okay, solid lines. Usually, it's solid if you have greater than or equal to, less than or equal to. If we have or equal to, it's solid. If we don't have or equal to, it's a broken line. It's a broken line when you have this or this only. It's a broken line, meaning it looks like this. Here, it has to be a solid straight line like that. Kind of the same we saw before when we have this, when we did the end of the, when we shaded the first degree linear equation, we used this. Sometimes we used this when it's not included. Same reason. So if we don't have or equal to, we use an empty circle. If you have or equal to, we use that shaded circle. Basically, the difference is here, the line itself is included as part of the solution. Here, that line is not included in the as part of the solution. Only the one side of the line, either the upper side or the lower side, not including the line itself. But here, when there is a solution, it's the line itself and one of the sides. We're going to see how to get one of those sides. So remember, if you have or equal to, your line must be solid. Otherwise, the line is broken. So in this case, obviously, the line is going to be broken. It's not going to be solid. So let's draw that line here. So it's going to look something like this, roughly. Okay, so you start by graphing the line first, the line that corresponds to this before you take care of this inequality. So think of it as a line, you graph it. Now we need to shade one of the sides. Either this side or the other side is the solution. Only one of them, not both. To figure out which side is good, we do what we call testing point. We need a testing point. Okay, so we take one line or one point from either side from you, it doesn't matter, and you check it. Take any point from this side and check it in this inequality. If it works, then that's good. If it doesn't work, you take the other side. So usually the easiest point to check, easiest testing point is this point here. What are the coordinates of this point here? The center of the graph. What are the coordinates of this point? What are the x's and y's? The x's and y here. That point is simply 0, 0. The center of the graph has these coordinates. Both x and y are 0. We're going to take that point, we're going to plug it here and see what we get. Based on the result, if it's a true result, we're going to shade this side. If it's false, we're going to shade the opposite of side of this point, which is basically here. So y, both x and y are 0, so y is 0. X is also 0. Minus 3. This cancels out. Based on this statement here, let's see, is this statement true or false? This statement here, is it true or false?
True.
True.
It is true. That's right. True. So the point test point T0 belongs to the solution side. That means this point here, which we took from this side, is good. Therefore, every other point on this side of the line is good. Any point you take from anywhere here to on this side will be a good solution. But if you take any other points from the other side of the line here, for example, here or here, you'll get something that doesn't make sense here. For example, 2 is greater than 100 or something like that. So in this case, we tested one point, it worked. So that's the point we're going to shade. That's the side we're going to shade. So basically, any point from this side will be a solution. So this entire side here, the upper side, is the solution of this inequality without including the line itself. The points that belong to the line itself are not solutions because as we said earlier, they're not included because we don't have what
not equal to. It's to be either greater or less than.
Exactly. So we skip that line itself. It's not part of the solution. Any point above that is a solution. So that's the whole idea of solving linear equations with graphing. Linear equations in 2 variables with graphing is basically, that's how it works. So if you have an equation in this line, in this form, or inequality in this form, it's easy to graph y-intercept, rise and run. But if it's in standard form, so this is not going to work. We're going to have to do the tables and find the intercepts as we saw in class before. So let's do this one here.
Professor, would you want to give me the quiz?
I mean, just do how much time?
Oh, no problem. Whenever you're ready. You just told me to remind you at 5. That's the only reason.
Oh, yeah, actually, I meant 5:30, like about 30 minutes before the end of the
No problem. You got it.
All right. So example, now solve by graphing. Solve the inequality. Shade the solution set. Okay, basically we're going to redo the same thing. This time we're going to do this equation, which is in standard form, not in our y(mx plus b) form. So 3x minus 6. So again, think of this at first. Just think of this as an equation, and pretty much everything we learn about these equations before applies here as well. So, so first, like I said, it's not in the y(mx) form, so we're going to have to find a couple of points that belong to this line. We find those by doing what we call the x and the y intercepts. So you're going to need a table like this, x and y. Then you start with a couple of zeros here. We're going to complete this table. We're going to find this value here, find this value. These are what we call the x-intercept. That's when the y is 0. This one here is called the y-intercept. That's when the x is 0. When the x is 0, it's called the y-intercept. Once we complete these, they're going to give us 2 points. We're going to plot the points here, draw the line, then shade one side of the line using a test point like we did before. So to find this point here, we know the y. We're going to plug the y here and solve for x. So it's going to be like this. Just going to substitute the y with 0 and solve this to find the x. This cancels, so 3x less than 12. If you divide by 3 divided by 3, x is less than 4. That's the first missing point. Let's put that over here. And then we're going to do the same thing for the other one. This time we have the x, we don't know the y. We're going to take the x, we're going to plug it again here. This will cancel out. We're going to solve this to find y. So 3 times 0 minus 6y is less than or equal to 12. This goes away. Negative 6y is less than 12 divided by negative 6. Y is less than negative 2. Okay, again, all this worked because we didn't have the chance, we didn't have the luck of having an equation like this with in y mx form. We would have done this in 2 seconds, but when it's in standard form, we have to do this. Or you can rewrite this in y mx plus b form if you would like to. Okay, our table is complete. Let's put these points, let's plot them in the graph. So the first one is 4, 0. I'm going to start from for x4, I'm going to stay on the y because the y is 0. So 4, 4, 0. The other one, we're going to start from x, 0. We're going to go down to negative 2. Start from x. This is the x-axis. x0, go down to negative 2. That's the line, or at least the 2 points that belong to the line. You just need to decide how is the line going to look like. Is it going to be solid or broken?
Solid.
I'm sorry, say it again louder.
Solid.
That's right, it's going to be solid because of this extra line here. Okay, it's going to be a solid line. Let me insert that line here. Try again. That's our line, solid, not broken. Good, so that's the first part. We're not done yet. With linear inequalities, you have to shade one side. So we're going to decide either to shade here or shade here. How do you decide again which side to shade? What do you do to find out which side?
Plug in the x and the y.
We're going to test a point. You can test any point from here. Usually this one is easy. Or you can test 1, 1. You can test 2, 1. Or negative 2, 2. Any point basically. But again, the most convenient one to test is this. Test 0, 0. This point here. Into basically this. So it's going to be 3 times 0 plus or minus 6 times 0 less than or equal to 12. These cancel out. That's the convenience. 0 minus 0. 0. Okay, is this a true statement? Is this statement true?
No.
Why not? Is 0 less than 12?
Doesn't the sign have to change?
No, the sign doesn't change. Only if you divide. If you divide both sides by a negative. That's when you flip this. But this turns out to be true, so that means this is the good side. No problem with this side. If this turns out to be false, then this side would be the wrong side. So in this case, both happen to work fine, so no problem here. And that's pretty much it. Maybe one last example here, and we're going to see what happens. Okay, let's do one more example. Let's see. Let's say y is less than negative 2x or 3. Plus I'm going to test this one, or maybe actually, okay, let's do this other example, same way. So we're going to need a graph. All right, so again, luckily, this is YMX form, YMX plus B. How do you graph this one again?
So you would start with the y-intercept, which would be 1.
That's right, that's the first point, 1 on the y-axis.
Now
Yeah.
I'm going to take a guess. Guessing that -2x/3 would be the run and the
Mhm.
rise and run.
Okay, let's start with the rise first and then do the run.
So you would go down
You said
2,
two.
Exactly, because it's negative, going down twice, 1, 2, and then
and then you're going to move over 3 times to the positive side.
exactly 1, 2, 3. And that's it. That's the line. Was very quick. Again, we didn't have to do all this solving here. This actually, we don't need to use inequality here. We can use just equal sign, but that's fine. Good. What's next? What do you do now?
Don't you check it by substituting by using the x and y coordinates?
That's right. We're going to check it. Let's draw the line first, and then we're going to check it. How does the line look like?
The line is going to be dotted.
That's right. It's going to be a dotted line or a broken line. So we're going to do this. Good. We're not done yet because it's an inequality. We still have to shade. If this was an equation like that, this would be enough. But with inequalities, one side is greater than the other. We have to shade one side of the line. And again, the test point.
0, 0.
That's right. Always take that test point 0, 0 because it's easy and convenient unless the line goes through it. If for some reason your line goes through that, then you can't use that point as a check because it belongs to the line. So you got to take another point. But most of the time, this would be the best option to use. We're going to plug those here. So it would be 0, -2, 3, 0, +1. This whole thing cancels out because this is 0. That's the reason why we choose zeros instead of some other number. So you don't have to deal with fractions and addition and subtraction. So that cancels out. We end up with this statement. What is it?
Not true.
That's right. This is a false statement. What do you think about the sides now? We took the point from here. It gave us a false.
We're going to shade up.
That's right. So this one would be the right one to shade. So this one here gave us false result. Any other point from this side will end up with false results. So we have to shade the upper side, the opposite side basically. So the solution is the whole side in green. The line inside is not included because it's broken. But any other point you can try for yourself. You can take, for example, 2 and 2, plug them here. Let's actually check that. Check, let's say this point here. This point is 1, 2. We know for a fact that we should get something true, not false. So because this is the right side, let's make sure. So y is 2, -2 over 3. X is 1, +1. Okay, and we can see what happens here. So negative. This number here is less than 0. If you add it to 0, so it will be positive and it's less than 2. If you don't want to do the math, you can see it that way. Or basically 1 is 3/3. Okay, 1 is 3 over 3. We're going to remove, we're going to minus 2/3 from that. How much is left? If you take 2/3 out of 1, we're going to have 1/3 left. Or you can do the regular fraction, addition, subtraction. As you can see, that's a true statement. 2 is greater than 1/3. And that confirms what we said. And you can check any other point if you want to, but at least use the test point to pick a side. And that's basically it. That's how you solve linear inequalities in 2 variables. That's pretty simple. Grab the line first. The line could be solid or broken. Once you graph your line, you take a test point, plug it into the inequality, and then shade one of the sides. Okay, every other example should be just like that. Same exact steps. Okay, any questions, everybody? Any questions on this?
No.
If you have any questions, please let me know before I give you a couple of practice problems. Okay, let me give you a couple of these to do on your own. So let's say solve by graphing. So let's say 2x plus 4, negative 8, and y is not equal actually, inequalities. Let's say okay, there's that one and another one. Okay, got two examples here. And actually, let's change this a little bit. Make it this way instead. All right, let's say just these two. Again, do them the same way we just did, and take a few minutes, give you 10 or 15 minutes to finish that. And we'll check that together once you're done. Everybody, let's go over these two problems together. All right, what did you get for this one? Or what do we need to do first here? How do we graph this line here? First one. Sorry, I probably lost your audio again. Can you hear me now? Okay. Okay, everybody again. Start with the first one. How do you graph it? Then I need to do the same thing as before. I'm going to repeat this basically. Going to find the x and y intercepts. So I'm going to start with the table. And basically find these two numbers here. So first, you know the y.
-4 and -2.
That's right. So first, if you plug this here, this will cancel. So you're going to have 2x. Not less than 8. If you divide by 2, x would be. Technically, we mean x here is 2. The second one, this time we know that x is 0. So we're going to plug it here. This will cancel. You're going to have 4y left. And if you divide it by 4, divide by 4, y is -2. So that's what we need to graph the line. So 0, 2, 0 would be here. 0, -2. So 0 go down to -2. How's the line, by the way? How is the line of this inequality? Is it solid or broken? This one here,
Solid.
right? It's going to be broken like this. Now I need to shade. So if you test, if you plug 0, 0 here, what do you get? 0 plus 0 is less than -8, 0 less than -8. Is this true or false? This statement here, obviously,
It's false.
that's false. So which side do we graph here? Is it
We're gonna go downwards away from the 0.
that's right, this side here, because the test point belongs here and it didn't give us any good results. So that's for that. This one is going to be even faster and easier because it's in the YMX forum. Okay, tell me how to graph this quickly here. How to graph this line? I'm going to start from.
Order 2.
That's right. I'm going to start from 2. From there.
Rise 3, 4 cross.
1, 2, 3 up, and 4 to the right. 1, 2, 3, 4. We're going to start from here. 3 up, 4 to the right. And that's the line. How is it?
Solid.
That's right. It's a solid line, as you can see here. So let me grab the straight line from here. Good, so that's the line. Still have to shade. Okay, so what do you think? Which side needs to be shaded?
Downwards.
Downwards, so that's right. So if you just look at it, you put 0 here and 0 here. It would be 0 less than or equal to +2. 0 plus 2, which is true. 0 is actually, it is in fact less than +2. That means this side, this point belongs to the good side. So we're going to shade this side. Any other point here from here would be good. So from here, so the solution here is the line itself, the solid line, and anything below that. For this one, the line is not part of the solution. The points on the line are not part of the solution. Anything below that is a solution. And that's pretty much how you solve your inequalities in 2 variables by graphing. So most of it is basically what we learned before about graphing the lines and intercepts and slopes, stuff like that. And the only added part here is the shading part. Okay, so don't forget about that after you graph your line. Any questions about any of this, everybody?
No.
Okay, everybody else? Any questions about all this?